All right, so here are the two things we're going to do with this regression line. So remember, our regression line is going to probably look something like this. Two things we're going to do. One is find predicted values. So if we have a given X, we have how many hours someone studied, we're just going to plug that in to the equation, pop out a Y. Technically, this is our Y hat. That's what a predicted value is. It's our Y hat. Y is the actual observed response variable, right? X is the actual observed explanatory variable. And then we have this Y hat, which is our predicted response. Another thing that goes hand in hand with this is a residual, which we denote with an E for error. Our residual is literally just how far off our prediction was from reality. We calculate this with Y minus Y hat, as you can see down here. This 100% is a note card thing to put on, right? It's a formula that you need to make sure you have in the right order. So sometimes for the residuals, it might be a two-step process, finding your prediction and then figuring out how far off that prediction was. But it is something that we're very interested in, like how good was our line at predicting stuff. So we're going to go ahead and do an example together. We have a scatter plot here of systolic blood pressure versus weight. So we have given the correlation, which we know is our little r, and then we have our regression equation given here. This is how it will always work on the exam. I will give you the regression equation. You're never going to have to calculate it, except for in the project or in that computer assignment. The only way you're going to have to calculate this is using StatCrunch. So it'll just pop out an equation for you. So looking through the first question, it says, suppose we know one person in the sample weighs 188 pounds and has a systolic blood pressure of 136. Predict the systolic blood pressure for a person weighing 188 using your regression model. This is terrible. Sorry, I'm getting mad at myself because I need to edit these notes to fix some of this typo stuff. I don't know how it went over the margins. I don't know. So anyways, first thing we got to do here, and the most common mistake students make, is that they don't take time to break down what we were given in terms of that Y, X, and Y hat that I was talking about before. So that all comes down to defining which variable is X and which variable is our Y variable. And there's a lot of ways to do that. So we're lucky enough that in this problem that we have a scatter plot, right? So we know what our X and Y axes are. That's straightforward. But that's not always going to be the case, especially on an exam. I'm not going to spend a lot of space putting in a picture of the relationship. So I'll probably just give you this equation. So another way to do this, sometimes the equation itself will have what the breakdown is. It'll say something like this: systolic blood pressure, usually with a hat over it because it's the predicted systolic blood pressure. And then you'll have the actual variables in their spaces that they would be in the equation. That's one way. Another thing, the only thing we're ever going to predict is our Y. So this last sentence here, predict the systolic blood pressure, this is telling us we're looking for Y hat and the systolic blood pressure must be my Y. The last way, which you're going to hope doesn't happen to you on the exam, is doing what we did with the cricket chirps and the temperature. We know it only makes sense if we're going to set up an independent and a dependent variable to have them set up in a direction that makes sense, right? Cricket chirps are not going to change the temperature, but temperature might influence how much a cricket chirps. So these are the three ways beyond the actual scatter plot that you could tell which one's which. So based on that, we can break down the rest of this. We have a weight of someone, which we just said was our X variable, right? So we have an X of 188. We have a systolic blood pressure, and this is a real systolic blood pressure of 136. And we know we're looking to predict the systolic blood pressure. So we're looking for a Y hat. And up at the top of the page, this is just plugging in our X. So in this case, we don't even need this Y. All we needed was the X. We're going to plug that into our equation, 1.1 plus 0.764 times that 188. And we'll figure out what that is. And just so you can see visually, this person is on our plot, right? This is 188, 136. This is who we're talking about. This is the individual we're looking at. So their prediction is going to be here, wherever the line was at that moment. That's what we're finding. So this is our y hat, right? That value for that particular x. So I will go ahead and pull up my little calculator. No, I'll pull out my phone and get this. Now I'm filibustering while I open up my calculator. You've probably already finished this. Should have paused my video. Oh God, I did something terrible. Ugh, I hate using my cell phone calculator. All right, so this is 144.732. And one really important thing on these problems, I wanted to do this in red, especially for the worksheet we'll be doing next week. If you don't put units, I dock you, and I dock you on every freaking problem. So you're going to lose half a point on every problem that you don't give me units on. So our y hat is all about systolic blood pressure. Unfortunately for this question, I did not tell you what the units of systolic blood pressure are, but they are millimeters of mercury. So on a test, I will always give you out what the units are, so that way you are required to put them. All right, so the last question here, number 2, says find the residual. And remember, this is just our error, how far off our prediction was. As soon as you see the word residual, you should be writing down the formula from your note card. And in this case, we have everything, because part 1 gave us y hat. And oh, that y that I didn't need before, now I need that, right? And the most common mistakes is that students just reverse these because they haven't labeled everything really nicely on their page, so they get in trouble. I can't do this math in my head, so I'm pulling out my calculator. This is a negative 8.732. And definitely show your work on this. I've had a lot of students who will write this and then give me out a positive 8.732. So just make sure that it is clear what math you are doing. Because if you do this and then give me a positive, I might not dock you anything, but if I do, it will be minimal. And then our residual is how far off we were in our y's, so this still has the same units, millimeters mercury. The only thing that doesn't have units is our R, our correlation coefficient. So hopefully that gives you a little preview of what it is we're doing when we are finding predictions and residuals using a regression line. I remembered something else. In addition to calculating these, I wanted to show you visually what this was. So the height of the actual point was our y. The height of the line at that particular x value of 88 was our y hat. And when we're looking at our residual, that's the actual vertical distance. That's what it was talking about. And remember back to the properties of the linear regression line. The point of our regression line is it minimizes all of these squared residuals. So it looks at all these different distances, squares them, and makes a line that minimizes this. I'll try to find I know there are a bunch of cool applets that people have made where you can kind of play around with the line and see how those residuals change. So I'll try to get that linked up on Blackboard for you guys so you can play around if you want to and see how that all looks.